So let's imagine that this is the situation. You've driven up here and you're flying from here. Your drone is somewhere here. And now you realize that the home point indicator isn't working properly, but there is still something going on in the information from the GPS, so you can still see some reading on the distance. It can be also done without the distance, but it's much less likely that you're going to find way home. So if we were completely able to realize where we are, we would have a straight line home, and that means that if we don't know where we are and we just need to be guessing, there's half of the terrain where we can go and it's going to be increasing the distance, and there's half of the terrain where if we go it's going to be decreasing the distance. And so if we imagine that you just pick a random selection, and if we say that you could go somewhere here, then you're going to see a decrease in the distance up to a certain point. So if we draw this out and then to this point, which is 90 degrees to you, you're going to see decreasing distance, and then it's going to start again to increase. So if you stay on that same course, you're going to fly away completely. If you adjust the course just slightly, it might get you a little bit of decrease again to a certain point, but then again you will eventually fly away. And if you imagine adjusting the course by some 15-20 degrees here, it won't ever get you home, because when you again reach a point where it stops decreasing and starts increasing, and you again do a little bit of adjustment, even if we say that if the adjustment can be left or right, let's say 15-20 degrees, you're always going to get 50% chance that you're going to get it right. But even if you're super lucky that 10 times in a row you get it right, that you should go to the right by 20 degrees, eventually you would just go in a very large circle around you and never get home. So in this point we have to be very drastic about it. So we know that adjusting the course by a slight degree, it won't really help. So we've realized that here it is the point where we've seen the lowest distance, and then obviously you're going to go a little bit further before you realize that it's increasing again. So in this point we have to be very drastic, because we know that going forward it's not going to help. Going backwards it might help just a little bit, but again only to this point. So we're not going to care about that few meters distance here that it took you to realize that the distance is again increasing. So what I'm going to do is I'm going to select two directions that are the only two directions that make any sense in this point, because you can either go 90 degrees right or 90 degrees to the left. You have 50% chance that you're going to guess it right, but if we have some information from the distance from the GPS, then if you select wrong and you go left, which means to 9 o'clock in this position where we were just heading to 12 o'clock, there's 3 o'clock and 6 o'clock is behind us. If you select to go to 9 and the distance is increasing rapidly, you have only one more position left that makes sense. And so you know very quickly, you have very quick feedback that you should go to 3 o'clock. And so you select a new course, and obviously we're not going to be perfect, and so you're just going to miss yourself again. And it's again going to be decreasing the distance up to a certain point, which is 90 degrees from you, but we don't know that. But you're going to see the distance again increase, and you're going to realize that again somewhere here, and it's the same situation as before. So forward was 12 o'clock, left is 9, right is 3. Continuing forward doesn't make any sense. Going back to 6, it doesn't make any sense. So you have to again do a flip coin, 9 or 3. And again, you're going to have a very quick feedback on the distance, where if you select correctly, you're going to see the distance drop. If you select wrong, you're going to see the distance increase, but that gives you a very quick information that you should just turn around and head 180 degrees in the direction that you've selected. And eventually you should get very close to a point where either you can recognize the terrain around you, which would be really good. Even if you have GPS, always try to first take off, do 1 or 2 circles around where you are, try to memorize what the features around you are, what you're going to see like from the air. So then when you get very close, you should be able to realize where you are. But even if we imagine that you are in a desert that's just yellow sand, then what you can do when you're very close and it doesn't seem to help a lot to repeat the cross method that we've done a few times, then we know that you're very close. Let's say that the distance reads some 200 meters, but even if it's in a forest where you can't really locate yourself, by that distance you should already be able to hear the drone. So that's another thing in the preparation, that if you know that you're going to fly to a certain point and you know that where you fly you should be facing to get the best range from the goggles, we know that you are looking in this direction anyway. And so if you're somewhere here and you do a throttle punch, you should hear it a little bit from the left ear, but somewhere behind you. So that should already give you some information on how to move to get back home. That also brings us to the very beginning, where it might seem lucky that we just selected a path that helped us go a little bit closer to home, and then we've done that cross diagram and again helped us to get back home. But if we imagine that here you're going to select any random direction to go in, so let's say that you go in this direction and you see the increase. So that means that we are going in a direction that is increasing the distance. So at that point, the first decision, if you see increasing distance, then the very next best thing to do is to go in 180 degrees from the direction that you've selected randomly. Because remember that we are dividing the space into 2 halves, where one is going to increase the distance, one is going to decrease the distance. With each step, we want to decrease the distance to get home as quickly as possible because of the battery. So when we see that the distance is increasing, any movement that you make afterwards, the first movement should be 180 degrees, because if you imagine that all of these positions that we could take as a random decision where to go, if we project 180 degrees from that direction, we're already in the good half of decreasing the distance. And also that's a little bit of a background to how to navigate through the terrain, that if you realize that you're lost, the first thing to do is to just stay calm. And instead of immediately starting to go somewhere, which won't really give you any information later, you should realize where you are. Take 360 degree rotation to realize what's where. So we can see some lakes here. So we have 3 lakes around us. There's a little bit of green here. So again, we have some very basic geometry around us. Don't overdo it. Pick out 3 or 4 features that will help you realize where you're going, because we have to then be going back and forth in those directions. You have to remember that if there's a lake here and you went in this direction, so this is lake 12, that the lake was at some let's say 10 o'clock from you, and if you go too far it's going to change. But that's why you have also the other features that then these should help you realize where it is if you need to go 180 degrees back from that direction. And then so we have tackled the first decision. We are on that decreasing distance course, and then even in this course it's going to work very much the same. So we're going to reach a point where it is 90 degrees from where we're standing, and here again we have to do that cross selection. So if we start seeing that the distance is increasing, it doesn't make any sense to go back. It doesn't make any sense to go forward. So we have 90 degrees left, 90 degrees right, and as I was saying before, it's then very quick feedback on how you're going to get back home, because you're getting very clear instructions where if you change the course slightly by 20 degrees, because we're afraid that it's going to start increasing again, that's actually the bad thing about it, because it's going to start decreasing, but not in full one-to-one, that you would travel 100 meters here and it would decrease by 100 meters, because we're off the track. So you're going to travel 100 meters here and the decrease in a distance will be some 20 meters. But eventually with these small changes, you would just end up in a circle if you're lucky. Or if you're unlucky, you're going to select the other course and you're not going to get clear enough instructions to go back. So we always need to keep the clock in mind. So it's 12, 3, 9, 6 and 9, where 12 and 6 are already out of the selection. So we have just 9 and 3, and that makes it quite easy to go back. If we have the distance. If we don't have the distance, it is also possible, but the chances of you recovering within the same time which you have on the battery are much lower, because instead of the distance, what you can use as the feedback on the distance is actually the signal strength from the goggles. And you want to push it to the limits. So if you have 04 and there's over 10 kilometers of distance, we don't want to go that far to realize that it's already starting to lose distance. So what we do in that situation is that you switch to angle mode, so that we're sure that if you're going to increase the altitude, it's going to more or less stay in the same place. It's not going to drift away rapidly. And then with that said, we know that if you go lower to the ground, that the signal is going to break off sooner than if you're very high above the ground and you have clear path in between you and the drone. So we have to lower the drone to put more obstacles in between us. And that way we see that if we're, for example, losing signal at the altitude of 50 meters, that's the first point, then we travel a little bit and then we again lower the drone. And if there's any difference that we can see in the signal, that can be our feedback on the distance from where we're standing. But obviously this is much more complicated, because there's going to be also terrain in between you and the point where you're standing. So the chances of recovering with this method are obviously much lower, because if you have working distance, is just a few coin flips, where if you select wrong, you have very quick feedback and you can adjust the course by turning around 180 degrees and immediately adjusting the course, so that it's going to take 3 or 4 cross-section decisions to actually get back completely.